All right, so as I said, I like always having some room at the bottom and the top. So I'm going to insert a couple rows here. Maybe I'll insert a few more. Because I think maybe I want to add something to the top. It's always a habit I have. Okay. Let's insert. There it is. All right, so there's all those X values, right? And so as before, I'm going to type in the frequency, which is what we saw in the box, and today it happens to be 60. So that means then my delta T is just going to equal 1 over that. Oops. Tab equals 1 divided by 6, this box, so not 6. Okay, so now I have a delta T. So some people write their dot number here, right? So we'll do just like you guys have started with. So we have dot number. View. And let's see, I'm going to center it horizontally and vertically. Let's make everybody the same font. And I'm going to wrap the text. Notice I put the units in right away. The way they do it in the manual is bad because they make separate rows for things like that, but then it doesn't do your best. It gives you problems with Excel. So it's better not to have a gap between the column titles and the first number in that column. Okay, so in principle, I know how many dots you have because I can just tell from your data. So there's my dot number. And so, as I said, now we want to do the dot number. Oh, sorry, I forgot to say equal. So this equals to open parentheses dot number minus 1 times, there's the asterisk, okay, and then that's our time interval there, and we need to make sure that the dollar signs are there, and enter, and now we can fill in all our times. And so we can play a few other things. Like first we'll put our borders. And let's see, we want to format these. This one here, I guess we want 3 decimal places. No more, right? Because we want to see that 0.0167. These, since we're saying our plus or minus 0.5, basically that this only needs 1 decimal place. And this is going to be 0.5. And we need to get rid of a decimal place. Okay, so there we go, right? Now, we need a delta X and a delta T, right? So we say, we want to get fancy, let's insert the symbol. And I happen to have it ready, but if you just look for Greek symbols, or in the Mac, it's math symbols. And I've got it there. And now this is going to be delta X. And that's in CMs. And then we need a plus minus delta X. Plus, and you have to put an apostrophe first, or it'll complain if you put the plus minus. X. Then we have a delta T, but in this case, we're not going to have a plus minus because we're just assuming that the time has no error on it, right? Well, basically what we're saying is that the, the error on T is much, much smaller than, the error on, X. Okay, we have a delta T. We have a delta, and the delta T is, of course, we know what it is. So there's two ways we could do this. I would say the best way is to actually calculate it, because that way, if we use strobe data, yeah, 6 of one, half a dozen of the other, right? So we can just simply say that it equals, in my case, E3, but I need to hit the F4 key. Because since it's a strobe, we know it's always equal to that, but we have to make sure to always look for the same cell, right? And then our delta X is, and give me a minute. So this one, in fact, we don't use. So let's get rid of that. So from now on, all these are not used. So we could just get a little cute here, and we use this pale here, and we'll gray them out, right? In fact, I think that's here as well, right? Because we need two of the X points, so we can't have one in the first, we don't have two until we get here, right? So that's going to equal to the final X position minus the initial X position and then we take that and we just fill it all in. There we have it. So get yourselves there, because I need to get something from the home page here. Whoops. Trying to get this window out of your way so you can see my, oh, wow, sorry. What happened there? Okay. So that you guys can see my spreadsheet while I'm going back to the Canvas page. And we need the resources, and we need propagation of error in the short form, because we need to calculate what's our plus minus delta X, huh? So we look on our table and we look for the one that shows the final result being determined by subtracting two quantities. And I'm just going to copy paste it to the spreadsheet, and that's here. And then we put it then I paste it. All right, so there's our template, if you will. And for us, sigma AB is always equal to 0. And in this case, little a and little b are equal to 1. And capital A would be our X final, and capital B is our X initial, right? So then we see that it's simply adding the two plus, squaring each of the two plus minuses, adding them and taking the square root. That's not so hard. So it equals SQRT of the plus minus here squared plus the plus minus of the other one. And they just so happen to be the same each time. But in principle, they could be different. Right? Then we hit enter. You notice it gets a little bigger. plus minus. But now we can just do it all. And we're not surprised that they're the same because remember, we called our plus minus x the same. Okay, so now we can determine our V, and to be strict, it's V average. And that's in meters per second. And this is going to equal to my delta x, right, divided by my delta t. And I think that's it, right? There's my, centimeters per second, excuse me. And already we see it's not 0, but that's okay because we know that if we don't pick the very first dot, which is probably impossible, right? Because it starts dropping before it hits the tape, right? So it's no big deal. So now we have all our velocities, and lo and behold, they're increasing. A little bit of a hiccup at the very end, but that's all right. And now we also need the, let's see, plus/minus of the average, which is centimeters per second also. Oh, make that a little bigger. There it is. Oh, okay. Well, we can also be a little cute. Just make, I like it when they're all the same size. So then you select them all. There we go. Beauty. And now we need to find out what's our plus minus V average. So we have to go back to our table. And we have two things being divided. So we need to pick out the template formula for two things being divided. And it turns out that it's the same formula, but for the two things being divided or two things being multiplied. And then now we have our new one. So this one is not needed anymore. And let's make that a little smaller. So at the end of the day, we see that the plus minus of two things being divided, it's going to be the quantity times the square root, and the sigma A plus minus A over A is called the relative error. And in this case, A is our delta X and B is our delta T. Now we're lucky though, because we've said there's no plus minus on delta T. So this thing reduces to just square root of plus minus delta X divided by delta X squared and square root. So we don't have to bother with the square root because we're not adding anything else to it. Are you following me? Should I write that out? You got it. All right. So the plus minus is merely going to be equal to, the V average times the plus minus delta X divided by delta X. Enter, and that's it. And it seems too high. What did I do wrong? Plus, I picked the wrong numbers. Try again. So it's the V average times the plus minus delta X, which is here, right? Oh, interesting. Oh, so it's going to be big in the beginning. There's just no way around it. Okay. Divided by delta X. Yeah, right. It's gotta be. Wow. That stinks. Why is it? Yeah, it's just that. So the relative error is 1, right? So hopefully they get smaller and smaller. Let's hope. So something's wrong. Oh, we said, yeah, that's right. It's point, you guys had it right the first time. And we're gonna say 0.5. Okay. Because half a millimeter, not half a centimeter. Oh, it makes sense. So now let's go down the line. All right, now I'm much happier. Yeah, and of course I do expect them to all be the same. Maybe, I would think it would change a little bit, but that's fine. All right, so we're almost home. Now we need an X coordinate. So this is another beautiful thing about Excel. I also know that when I graph things, I like to have them right next to each other. So I'm just going to now insert. See how I clicked on the whole column by clicking on in my case, the J. So you right mouse click, insert, and I want now T average, and that's in seconds. And again, we don't care about any plus minus, so that's going to equal to average of our 2 time points way over here is the middle of the 2 point. I have my delta t x and my delta t. This is the midpoint. And once again, we go right down the line. And I probably want some more decimal places. Okay, so we're just about ready. Now, unfortunately, it would be nice to just do this, but because of the gap here, it gives Excel gets funky about it. So I will have to do this and add. Oops. So now I can do insert. Want a scatter plot. And look at that. We were expecting a straight line, and we pretty much have it. We have one outlier. Remember I said something was funky at the end. Well, you know what? One thing we're allowed to do since it's at the end, watch this. I am going to nuke it. Nobody will get mad at that. If it's at the end, you're allowed to do it, right? It's basically I'm sliding the ruler back and forth, right? It's all. And if in principle, we could eliminate the first 2 or 3 points, but we can keep, they're not so bad. You're not allowed to remove them in the middle though. All right, so we're on the way. We could, one trick I've learned is now insert the error bars now. That way you don't get it on the fit line also. And the only thing is we can't pick or choose. So we need to now, you double click on it, you get the gray bar on the right. And if we have a PC, we can just use this drop down box. If you have a Mac, same thing as a PC, click, see how it says chart tools at the top? Click format, then you have the same drop down box. So X, error bars. Now we click this icon, it looks like a graph on the right, and we say a fixed value of 0. And then we go to the Y error bars, and we've done it. Now we're going to do custom. And that's going to be all these guys here, the plus minuses. Is it working? Yeah. Okay. One. And here's a little trick. You don't have to start at the top. There. And okay. And we see the error bars are pretty darn small. And that's, and again, you see how the spread on them? Well, and the error bars are smaller than the spread. That's basically telling you that we don't have a good estimate of our error bars. One thing I'm going to do here, I'm just going to make the dot and make it a little smaller because the dots, the markers. I'm going to see if I can. Now I can see the error bars. Okay, this is a matter of taste. It's not something I would grade you on, but the more you jazz up a graph, right, the better grade I'll give you on. And another thing that's missing here is, well, we can fix this when we make the fit line, because right now, if I inserted a legend, it doesn't know the name of that. It just, because I didn't pick the top, it just says series 1, but we can fix that at some point. But we'll do that and after we insert the fit line. Okay, so let's get this out of our way. We need a fit line. We need you guys all understand what residuals are? No, okay, so we'll make separate columns. The residuals squared. Okay. And then we need, let's see where we'll put our fit parameters. We'll put the slope, and we can make a guess of the slope. Looks pretty big, actually. It looks like it's going to be, if it's 100, it looks even more than 100. Well, I'll just try out 200. And I just look at 2 points, right? And I see the first T average is 0.0083, and then I go to 42, right? So I multiply by 100, I'm at 0.8. Boy, it looks like I'm about 1,000 maybe. So let's put 1,000, get started. And then y-intercept is, well, we kind of think it's going to be 0, but it's all right. And then we need, so let's do sum of the residuals and then sum the residuals squared, because it sounds like you guys are not keeping up with your pre-labs. So we'll see the two of them. So the fit line is, it's a linear fit, right? So it's y equals mx plus b, y equals the slope times the x coordinate plus the y-intercept. So that means the slope, that box, that we need dollar signs. So either you hit F4 or you just click you have to click inside, and then you can add a dollar signs. And now that's the slope time, and the x coordinate, x value is our T average. We don't need dollar sign there, plus the y-intercept. And now we do need the dollar sign. So hit F4, we get it. You will hit enter. So yeah, something doesn't seem right here. But okay. Now we can fill all those in. And now we can put that on add the fit line. So now we highlight the graph, we right mouse click, and we do select data. There it is. The first thing we'll do is we'll edit the series 1, and that's simply all we're going to do is pick the title. What's nice about, you can hand type a title in there, but then you have to take several steps to change it each time. If you pick a cell, then all you have to do is change the cell and it automatically updates. And see, notice if you look at my graph, it says V average in there. Now we want to add one. And the series name, of course, is FitLine. The X values are the same as the data, which is our T averages. And the Y values are, of course, the FitLine. And okay, and as we've seen before, we want it to actually be a line. And so we have it highlighted, we have the gray on the right, and up to chart tools, and PC users can just go here, and Mac users have to go to the upper left-hand corner. So we want a line. You can pick any color you want. I like red for a fit line. And make it really thin so it doesn't obscure the data points. And then I want to get rid of the markers. And let's see, there we go. And so maybe we can play with our legend here. So there's all kinds of formatting things we can do. We can fill it in with white paint so we can see it better. All right. And we know, okay, now we have our, let's do our residuals and residuals squared. So a residual equals the data minus the fit value. So you'll see that if the point is above the line, it'll be positive. If it's below the line, it'll be negative. I don't know if at the moment, if we'll see any negatives come up. Doesn't look like it, but we can do something about that. So if I just move the curve, let's say I move the curve up a little bit. You see the fit line moved? That's the beauty. Now you see I got some negative because some of the dots are below. So this is when, before the advent of computers, we would say, we want to say equals the sum, open parentheses, and pick all those residuals. And what we would do is we were told that we want to have equal numbers of dots above and below, and also the distances are about the same. So what we would do is we would try to monkey with this until we could get the sum of the residuals got bigger, so we back up. So you would find that at some point you could create the sum of the residuals equal to 0. The problem with that, if you want to ask a computer, is that you could do something like this. And then if I make this, let's see, minus 200, you can see that eventually I could get the sum of the residuals to become 0. You can start to see the possibility of it, minus 250. So you see now I made the sum of the residuals get smaller and smaller, but obviously that's an absurd result, right? So if you ask a computer to use the sum of the residuals, it will say, hey, look, I brought it to 0. And you'd say, oh my God, what am I gonna do? So that's why we need what's called the residual squared equals this squared. And of course, we need to format that. And now we take this, fill it in. And you can sort of see that there's, it's sort of, if you look at it carefully, you can kind of see it already. It's sort of a parabola. Because in the very center where the red line crosses, of course, the residual would be about 0, but we really care about the sum equals the sum of all those numbers. Now what you'll see is that if I go back to the numbers that made the sum of the residuals close to 0, you'll also notice that the sum of the residual squares go down, right? And in fact, you notice that the sum of the residuals is actually bigger than what I just had. But so just to reiterate, the sum of the residuals say this is good, but the res square says no way. And now you see both of them say it's better, right? Now this is as far as we've been going. And now, if this is truly free fall data, then we can say, all right, what about, let's try 980. And then we know we had, so we guess this is going to be about 42, not too much. And so you can keep monkeying with these numbers until you get the smallest possible sum of the residual squared. But now, one thing we've been doing, I've been showing students. So I'm just gonna format this. All borders. So another thing we can do though is we can ask Excel to do it for us. Now you go to the data tab here, and way over here there's a thing called solver. Now you may not have that yet. Okay, what the hell? Of course I know. So I want to minimize, and now I want to pick the sum of the residual squared. And then by changing what? Well, the slope and the y-intercept, so I pick those two. And we uncheck this box. Let's see what happens. Looks like it's okay. And look at that. It's a little bit odd. I would have expected, oh, V average. Okay, so that isn't the V sub 0 after all. And in fact, we see that that those points dance around a little bit down there. All right, so now we have our graph, we have our XT data, we changed it into VT data, we fit it, and now we have a slope, and the slope is the acceleration. And in this case, we're measuring the acceleration of gravity directly, so we compare the 968 to 980. And then it's a simple matter to just say, okay, what if I made this 980? Yeah, that's easily acceptable. Maybe 1,000. That's too much. I'm saying is it believable, right? So, okay, I'll say 980 is okay. So then I'll say that I have 968 plus or minus about 20, right? Or plus or minus 10, because it's almost 970, right? And what we're going to learn next week is that there's a special, I'll give you guys a heads up, a leg up on other people, we're going to create another column. And just because I want to maintain separation, I'm going to go insert. And this is going to be called a chi-square. And the chi-square is just equal to the red squared divided by the error squared. And in our case, they're all the same. But this is in case one of the error bar could be bigger than the other, so it would downplay the ones with large error bars. So now we do some chi-square, and then this equals to some of all these guys. Oh, no, wrong one. These guys. Okay, now watch this. First of all, we want to use solver. Now instead of the red square, we use the sum of the chi-square. It should pretty much stay the same. If we had different size error bars, it would change. No, it didn't change. Okay. Now here's the rule. How do we get plus minus slope? We get plus minus slope by varying the slope so that the sum of the chi-square changes by 1. So at the moment, it's 172.75, right? So watch what we do. We put in, we'll just call it plus 1, although it could complain. No. It didn't do that. Okay. Plus 1. So we're going to go equals to the sum of the chi-squared, literally plus 1. The reason is that this is rounding off, right? So I'm going to take this, I'm going to copy it. Now I'm going to tell it, all right, I want you to make the sum of the chi-square equal to that value, Control V. Oh, it didn't work. Why not? Okay, so cancel that. It didn't work. So I just want to do is the best thing is to get a few more decimal places. And so let's add a couple. Okay, so now we go data. And that's the solver. So value of 173.7452. And we only want to change the slope, not the y-intercept. And let's cross our fingers because sometimes it worked. Isn't that great, huh? So now we're going to call this our plus slope. And that's going to be, so what I'm going to do here is I'm going to copy this. There's no way to do it one step, unfortunately. And now what I'm going to do is say paste only the number, the value. And then I'll just do solver one more time. And once again, I say minimize it by changing the slope and the y-intercept. And then we say solve it. Okay. Now here is our plus minus. That's going to eat. So my plus minus, I'm getting tired. Oh, there it is. Plus minus slope, enter, equals this, equal sign, Harry, equals the actual slope minus this guy And okay, it's going to be a negative number, so I guess I should reverse them or use absolute value because it doesn't matter. So we're going to say 968.8 plus or minus 2.5. And it makes sense, right? With so many data points, I wouldn't expect very much wiggle room, right? And you noticed before I got a pretty big, I said like 20 or something like that, right? But that's exactly how it's done. You construct the chi-square, the sum, and you vary your fit parameter until it goes +1, and that's your plus minus. Pretty sweet, huh? So again, I mean, I don't expect you to walk out of here knowing all this stuff, but now you have this somewhere, and in the future, if you have to, if somebody tells you, hey, I need you to do a fit, you'll go, oh, I know what that is. I can't do it right now, but I know I can get it to you tomorrow, right? Or something like that, right? That's all I hope for you guys. Right? So now you know everything. I'm going to stop the recording. And now you need to do this for last week's lab. And so what I'm going to have you do is